Hello everyone, my name is Tawfiq from Tenet Technetronics. I'll be giving you a brief introduction on the components that we have. Hello everyone, today I'll be giving you an introduction to a BC547 NPN transistor. One element that has revolutionized the technology in the past decade is known by its name, a transistor. The transistor have enabled some humankind's biggest leap in technology. Transistors certainly helped start the computer age and also revolutionized the computer design and spawned an entire industry, as you can see in America, that is called the California's aptly named Silicon Valley. So this is a BC547 transistor, as you can see here. So it is named a transistor because it comes from two terms, that is transfer of resistor. It means that the internal resistance of transistor transfers from one value to another value. So depending on the biasing voltage applied to the transistor. Thus it is called transfer resistor, that is a transistor. This BC547 is an NPN bipolar junction transistor, or you can say an NPN BJT, which is a semiconductor device used to amplify and switch electronic signals and electrical power. Transistor works also wonderfully for many computer applications or for productions. So with smart engineering, transistor help computer powers to large numbers of calculation in a short time. As you can see, a simple switch of operation transistor is what enables a computer to complete massive complete tasks. In a computer chip, transistor just switches between two binary state, that is a 0 and 1. So this is the language of computers. So one's computer switch can have millions of transistors, continuous switching helping complete complex calculations. So this BC547 transistor, or normally a transistor, is made of silicon, a chemical element found in sand, which does not normally conduct electricity. It doesn't allow electrons to flow through it easily. Because electrons have a negative charge, silicon treated this way is called an N-type, negative type, or else called an NPN transistor. So this is an NPN BC547 transistor. So this NPN BC547 transistor can be used in two different modes. As we know, one is forward bias mode and the other is the reverse bias mode. So in the forward bias mode, the electrical current can easily flow through it. So it just acts as a closed switch. However, in a reverse bias mode, the current through it practically is zero and thus acts as an open switch. This transistor BC547 requires a fixed DC voltage to operate in the desired region of its characteristics. So this is also known as a biasing. So we just see a demonstration of how this BC547 can be made to work. Now we'll be seeing a demonstration of a BC547 on how it works. So for this demonstration, we'll be using likely a BC547 transistor. As you can see here, a 3-pin, as I explained before. We'll be using a photoresistor, and we'll be using a 4.7 kilo ohm resistor and 470 ohm resistor and an LED to blink. And we'll be using a 12 volt power supply. So now I'll be just giving the connections and you can see how a BC547 works. So here initially I just connect the BC547. Before that I could give a connection, I just want to say what are the pin in BC547. So as we know, the middle pin is always the base, and this pin is the collector, and this is the emitter. Or I could say like this: this is the collector, this is the base, and this is the emitter. So from the collector, it is connected to the LED which blinks, and the emitter, it just is grounded, and from the base we give the power supply. So we'll just see how this BC547 works. So I've just connected a BC547 to the breadboard. Now we'll connect the photoresistor as we saw in the diagram before. So here photoresistor, this is connected to the base. So one end is given to the base, and now we connect our 470 ohm resistor to other end of the photoresistor, and we'll connect the other one. Now I connect an LED. So the positive is given to one end of the LED, and this is given to other side. So this, in order to stretch a little more, it isn't fitting properly, so I'm just fitting now. So now I think we have fitted. So this LED, I'll have to shorten it. I'll just fit it here. Okay, so now I've connected the positive to one side of the resistor and the negative to the collector of the BC547. So now this emitter, as I told, is given to the ground of the BC547 transistor. So now we connect our 4.7 kilo ohm resistor to the base of the BC547 transistor, and the other end of the resistor is given to ground. Okay. So now we saw this. Now I'm going to give the power supply, and I will just check how this BC547 and this photoresistor work in conjunction. So once I give the power supply, this will allow the voltage to flow, and this photoresistor, based on the light supply available, will also pass. So we have two traffic lights control, you can say, like this is one of the traffic light control and this is another one. So I'll just give the power supply and we'll just check. So this photoresistor is already supplied with the light. As you can see, it is already bright in this room. So as soon as I give the connection, this LED should blink. So now we'll see this connection here. So the positive supply is given here and the negative. Sorry, I was giving the opposite way. So now we'll just see the negative here. So now we can see this LED blinking now. So now, as I told, this BC547, how it works. So once the power supply is given, it acts as an open switch, a closed switch. It allows the passage of current to flow through the base from the collector, and from that you can give to the photoresistor. So a photoresistor passes the current to flow when there is a light supply or there is brightness. So as we see, you can see here brightness here, and it allows the flow. So if I block the flow of light falling on this photoresistor, this light is not. So our main concern is BC547. So we can see how a BC547 allows from the base through the photoresistor, and this LED blinks. So this is a simple working principle, or you can say a simple demonstration of a BC547 transistor. Thank you for watching this video. If you have any doubts or queries, you can log on to www.tenettech.com, or you can drop a mail to info@tenettech.com.